In this video, we will be discussing markup as well as optimal markup. Here we have a problem where a store owner wants to sell an item at a 50% markup. If the item costs the owner $12, how much is the store owner going to charge for that item? So with markup, what we want to do is we want to figure out how much the price increases from the cost when we sell it at retail. And we would use a specific formula for this purpose, which is price equals the cost times 1 plus the markup. And by using this formula, we can find what price we would charge given a markup and a cost for an item. So if we plug in what we were given, we have price equals a cost of $12 times 1 plus 50%, or 0.5. And if we plug this into a calculator, we would charge whatever good we are selling at a price of $18. So given a 50% markup and an item that costs us $12, we would charge a price of $18 to the public. Now for part B, we have if the elasticity of demand is negative 1.3, what is the optimal markup for this item? So with the formula that we used before of price equals cost times 1 plus m, or the markup, this doesn't take into account consumer demand. It only takes into account whatever markup we want to use, which could be detrimental to our sales. What optimal markup does is it takes into account our elasticity of demand and produces the optimal markup we want to use in order to maximize our profits. So using a different specific formula for optimal markup, which will be denoted by OM, we have optimal markup equal to 1 over the absolute value of the elasticity minus 1. And so if we plug in what we know, we have optimal markup equals 1 over 1.3, because we take the absolute value, minus 1. And if we plug this into a calculator, we find our optimal markup to equal 3.333, or 333.33%. So since we have an optimal markup so large, we can have a much higher price because our demand for this item is fairly high, according to the elasticity. So if we were to find the price we would charge with our optimal markup, we would use the markup formula from before of price equals our cost of $12 times 1 plus our optimal markup, which is 3.333. And by using a calculator, we find our price using the optimal markup to be $51.96. So due to demand being high for this item, we would charge a much higher price than what we paid for it. And due to it being the optimal markup, we would reach our maximum profit that we could achieve by selling this item. Here we have another problem where a different store owner wants to sell an item at a 75% markup. If the item costs the owner $16, how much is the store owner going to charge for the item? We would use the same markup formula as before of price equals cost times 1 plus the markup. And by plugging in what we know, we have price equals a cost of $16 times 1 plus the markup of 75%, which is also 0.75. And if we plug this into a calculator, we find our price to equal 20.21. So if we want to mark up this item at a 75% markup and it costs us $16, we would charge this item to the general public at a price of $20.21. Now for part B, if the elasticity of demand is negative 4.8, what is the optimal markup for this item? Now we want to find an optimal markup that will lead to a price that will lead to the highest profit we can achieve. So using the optimal markup formula of 1 over the absolute value of the elasticity, which is just a positive 4.8, minus 1, and by plugging that into a calculator, we can find our optimal markup equals 0.4545. And if we were to write this as a percentage, it would be 45.45%. Now, if we want to find the price that will lead to the highest profit we can achieve using our optimal markup, we would use the markup formula, which is price equals our cost of 16 times 1 plus 0.4545, which is our optimal markup. And if we plug that into a calculator, we find our price to equal $23.27. So as before, we charged a price that was too low, so we weren't optimizing our pricing strategy enough to reach the highest profit we could achieve. And by using the optimal markup, we can see our profits for the store increase due to taking into account elasticity of demand. This leads to less detrimental effects that would be seen from applying a general markup of a certain percent throughout the entire store's inventory, which can lead to certain items being very popular because their price is much lower than demand, leading to a shortage, or their price is much higher than demand, leading to a surplus. That will conclude this video on markup and optimal markup.